Welcome back to this video where we are going to be talking specifically about another type of sequence called the geometric progression. Okay, so different from the arithmetic progression, this is going to be called GP, okay, from now onwards. Not Jarabo, but geometric progression. Okay, so let's just jump right into this. So once again, geometric progression is basically just a sequence. Okay, so let's just take the sequence over here, which is an ordered set of numbers. And then let's say here is, for instance, 3, 6, 12, 24, 48, and then it just goes on and on and on. Now you can see that the relationship between each term, right, is not a constant difference anymore, right? Because from here to here, you plus 3, and then here to here, you plus 6, right? And then from here to here, you plus 12, right? So actually, the relationship between each term is no longer a constant difference because it's not a constant difference, but rather it's a multiple. And from here to here, you times 2, from here times 2, from here times 2, and then from here times 2, and then, you just keep on timesing 2 forward, forward, forward lah. So how do we derive what is the general formula for this? So I'm just going to show it to you over here. So T1 is 3, right? And we also can write it as 3 times 2 to the power 0, right? Because 2 to the power 0 is essentially just 1, right? We know that this is essentially just 1 using your indices. But I write it this way so that it's easier for you to see the pattern moving forward. For the second term, T2, okay, I'm just going to annotate at above over here also. T1, T2, T3, T4, T5, right? Now for T2, this is essentially 3 times 2 to the power 1, right? And that's how it actually gives me 6 over here, right? I'm just going to write 3 over here. Now for T3, how many times must I multiply 2 from 3? So I start off at T1, which is a value of 3. I times forward 2 how many times? I will actually times forward 2 times, right? So 2 to the power of 2. As you can see over here, I times forward 2 times. So this over here will give me a value of 12. Now T4 would mean that I times forward 2 how many times? I will times forward 3 times. So it's 3 times 2 to the power 3. Right? Because you see, from 3, I times 2, times 2, times 2 to get 24. So times 2, 3 times to get 24. So I'm sure by now you are able to spot some pattern for yourself, right? What is the general term of this geometric progression? The general term for this geometric progression will therefore be Tn equals to 3. Everything starts from the first term, which is 3. Then I multiply forward how many times? So for the n term, I will multiply forward a total of n minus 1 times, right? And therefore, this is the general term for, okay, I won't say general term, I'll say the nth term, right? The nth term for this GP. But of course, to generalize it, right, as a formula that you can apply to any GP in the world, what would the GP look like? Or what would the formula look like, right? So I'm just going to draw a line here, and I'll say, in general, for any GP, the general term essentially is T1 times the common ratio or the common multiple. We'll call it ratio from now onwards, so we'll times R to the power of n minus 1. Okay, where T1 is the first term of the GP, similar to the 3 over here. And then R is the constant multiple, right? So R over here is the constant multiple, or you can call it the ratio, however you want to remember it. And then n minus 1 over here is the number of times I need to multiply R to T1 in order to multiply forward to Tn. And this is basically the general formula for GP. So if you understood how I derived the general formula for an AP in the previous video, then this should also make sense to you, right? Because it's actually quite similar. It's just multiplication of moving it forward. Now, just some common questions that I usually get is, why don't we times 0 over here, right? Why do we have to start from T1? It's because everything starts from T1, right? You realize that if we start from 0, then it wouldn't make sense, because if we start from 0, right, there's no way we are going to get to T1, which is 3, right? So everything, whether it's a GP or an AP, all starts from T1. Then from T1, it's all a matter of how many times you move forward. And how many times you move forward is n minus 1 times. And for an AP, you move forward by a constant difference, and that's why we plus. But for a GP, you move forward by a constant multiple, and that's why we times. Okay, that's the concept. And any questions, let me know in the comments. If not, this is the mastery question that we're going to try our hands on to actually, make sure you understand this concept. So make sure you have already taken down the formula on the screen over here. If not, right now, we are going to be tackling this question over here. Feel free to pause this video. If not, I'll get right into it. Now, we are given a GP H, right? So H over here is the sequence, and it's given that all the terms are negative. So why is this so important? I'm going to be explaining this later on. Okay, but when they say all terms are negative, this is a crucial piece of information. don't overlook this. It is given that the first term is minus half, the sixth term is 9 over 4 of the fourth term. Find the nth term of this geometric progression. So since it's called h, right, I'm just going to let the nth term of this GP be hn. Okay, because it's h, that's why I follow it. Now, I know that hn is basically h1 times r to the power of n minus 1, where r is the constant difference. And I know that h1, which is the first term, is negative half, as given by the question over here. So I know that hn is minus half times r to the power of n minus 1. So they tell us that the sixth term is 9 over 4 of the fourth term. So this sentence over here tells me that my h6 is 9 over 4 of my h4. So I can just, use this formula and then just sub inside here, right? So I know that my negative half times r to the power of 6 minus 1, which is essentially h6, is 9 quarters of my h4, which is minus half, times r to the power of 4 minus 1. So over here, I can simplify this entire equation first, because I can strike out these two, right? And then this one I know is 5, and then this one I know is 3, right? So I have r5 is 9 over 4 times r3, given over here. Now, bringing the 3 over to the other side, I will have r5 divided by r3 is 9 over 4. And r5 minus 3 is 9 over 4. Therefore, r2 is 9 over 4. So r is plus minus square root 9 over 4, right? Which will give me 3 over 2 or negative 3 over 2. Now, at this point, you have two possible values of r. Which one will you take? So that's why I say that at the start of the question, it's very important that you clearly understand the constraints of the question. It is given that all terms are negative, and your starting term is negative half. So if your starting term is negative half, in order for the next term to remain as a negative number as well, right? When you multiply the constant r to it, your r itself has to be positive. Because if your r is negative, okay, so suppose, let's say your r is negative 3 over 2. I times negative 3 over 2 over here, right? I end up with positive 3 over 4, which contradicts the question's requirement that all terms must be negative. So we immediately will actually reject this as all terms are negative. Because in order for all terms to be negative, the constant r, the ratio, must be positive. Because you have a negative times a positive, you'll be negative. So we know that your r value is 3 over 2 over here. Okay, so this is why the constraint of the question is so important. So we can actually sub it back inside here. So I know that hn is just negative half times 3 over 2 to the power of n minus 1. Right, and then of course we can further simplify this, right? But from here onwards, it's just your indices. So it's negative 1 over 2 times 3 to the power of n minus 1 over 2 to the power of n minus 1, which is just negative 3n minus 1 over 2 times 2n minus 1, which is negative 3n minus 1 over 2n, right? And that's the final answer to this entire question over here. So I just sped right through the last part because it's just your simple laws of indices that you learned a long time ago. But all in all, this is why we reject negative 3 over 2 and we only proceed with positive 3 over 2. Okay, if not, this is the end to the introduction to the general term of a GP. If you want more questions like this and more videos of me breaking down the questions and breaking down exam level type of questions, make sure to click the link in the description to check out my library of more videos and more resources that I put my heart and soul into recording. Okay, if not, I will see you in the next video to actually run through with you the concept of the sum of the first n terms of a GP. And I'll see you there.